In this video, I will guide you through the configuration of 3 different types of static routes known as the simple routes, the default route, and the aggregate routes. In the previous video, we could only ping directly connected neighbors on their far end IP addresses which are within the same subnet. This is because these are the only addresses or subnets known by the local routers. Static routes are a method of populating the routing table manually, hence allowing traffic to reach non-directly connected networks. With IP routing, each router only needs to know the next stop IP address to reach a destination address or subnet. So if every router has the correct information, the traffic should ultimately get to the intended destination. The first part of a static route is the subnet we are trying to reach. So you must always include the subnet mask. The next stop is the known IP address to reach the destination subnet. In our case, it will be the far end interface IP addresses and not the near end. Let us now configure a simple static route from PE1 to PE2 system interface IP address, and we do the same thing from PE2 to PE1. We go to the CLI, and on PE1, let's issue the show router interface to see what interfaces we have already. For that, we issue the show router interface command. We have 3 interfaces here. One is the system, the other ones are going to the other PEs, to PE2 and to PE3. For now, let's ignore the PE3 on PE1. This is for future exercises. So let's go to PE2 and issue the same command. So on PE2, show router interface command again. Again, we can see we've got 3 interfaces here. One is the system, and then the 2 other interfaces are going to the other PEs as well. But like I said earlier, let's ignore the one going to PE4. For now, we focus on interface to PE1. So to begin with the configuration of a static route, let's also view what we currently have in our routing tables on both PEs. And for that, we issue the show router route table command. As you can see, the routing table corresponds to the 3 interfaces that we have, and they are all local types, and protocol is also local. We issue the same thing on PE2, show router route table, and we should see the same thing here. So again, the reason we're not seeing to PE4 is because it's currently down. So that's why it's not shown in the routing table. So ignore that for now, like I said anyway. So again, from the routing table of PE2, we can see the system and the interface routes on this PE. So let's go back to PE1 and configure a simple static route from PE1 to PE2's system interface. For that, we issue the configure router static route. Now remember, we're trying to get to the PE2's system interface IP address, which is 150.10.0.1/32. Because it's the intended destination, we have to always include this subnet mask. So we issue the 150.10.0.1/32. And the next up is our far end interface IP address of PE2, which is the .98 address. So we go back to PE1 and complete the static route configuration. We end it with next up as 140.10.0.98. Hit return. That concludes the static route from PE1 to PE2's system interface. We now go over to PE2 and do the reverse. So again, we go configure router static root, and the PE1 system interface IP address is 140.10.0.1. So we go back to PE2 and complete that as well. So it'll be 140.10.0.1/32. Next up will be the PE1's far end IP address of 97. So we complete the static root configuration as 140.10.0.97, hit return. Now before we start to verify our configuration, let's now go back into the routing table of both PEs and see what we have or what has changed. Show router root table, hit return. As you can see, there's an additional route that has been added to the routing table, and the protocol type is static, which means this has been statically configured. We should see the same thing on PE2. Show router static root. Okay, that's the static root we configured, but we actually wanted to see the routing table. So show router root table. Again, as you can see, we have an additional root in the routing table, and the protocol type is static, and it's now got the type of remote. So let's verify we can reach the system interface IP addresses from both PEs. But before we do that, let's initiate a debug on PE2. So to do that, if you remember, it's configure log ID. You can choose any ID from 1 to 100. For our purpose, let's go for 33. Hit return, and it's from debug trace to session. We then exit out of that and start the debug. So debug router IP ICMP, hit return, go on to PE1, and let's now ping the PE2's system interface IP, which is ping 150.10.0.1, hit return. You can see we're getting replies from PE2's system IP. If we go back and check our debug, let's go to the top and see what this has done. So the first ICMP packet that came in is saying to us it's coming in from the IP address of PE1 system IP address of 140.10.0.1, and it's going to the PE2 system IP as well as 150.10.0.1. Now PE2 is replying and P1 is also replying. This shows us that, I mean, without the static root, we couldn't have done this before. So the static root is now allowing us to reach non-directly connected networks, which is the intended, what we actually wanted to do. So for now, we are going to stop the debug. Before we move on to the configuration of the default and aggregate routes, I want to show you the difference in the way ping utility works when you ping a remote destination and a local destination. So I've gone ahead and I've enabled the debug again on PE2, and on PE1 we are going to ping, let's just clear this a bit. On PE1 we are going to ping the far end interface IP address of PE2, which is the 140.10.0.98. We're getting replies. We then go over to PE2 and have a look at the ICMP packets. You can see that the first packet is coming from PE1's far end IP address of .97, and it's going to PE2's interface IP address of .98, and the reply is going back the other way. Now if we now initiate the ping to the system interface, which is the 140. This is not a directly connected IP address. It is a remote IP address. So let's see what happens with the ICMP packet when we issue this. Again, let's put a bit of gap so we know where it starts. So we issue that ping command again to the system interface of PE2. We're still getting replies. We then go over to PE2 and see where that ICMP packet is being sourced from. So as you can see, the ICMP packet is being sourced from PE1's system IP address of 140.10.0.1 and is going to PE2's system IP address. Now, the major difference I'd like you to identify here is whenever you issue a ping to a local IP address, if the router has the same subnet locally, it will issue that ping from that local IP address to the local destination. But if the router does not have that destination IP address, it uses the system interface as the source. So this sometimes could be confusing when you're trying to troubleshoot. Just take a note. When you ping a remote destination without specifying a source IP, by default, the NOKIA 7750 service router automatically uses the system IP address as the source. Just for you to know. We will now proceed to our next exercise, which is the configuration of aggregate and default routes. Let's proceed by removing the previously configured simple static routes. And to do that, we issue the configure router no static route going to the 150.10.0.1/32 network with the next up of 140.10.0.98. It return that's gotten rid of that static route. To double check, we go into the routing table on router CE1 just to make sure that's taken out. Yeah, it's gone. So we go over to PE2 and do exactly the same thing. So configure router no static route. If you tab, by the way, it will tell you what the commands are. In our case, because we don't have a lot of configuration, it's easier. But when you have a large configuration, you should know exactly what route you're trying to take out. So in our case, it's 140.10.0.1/32. Next up is 140.10.0.97. It return show router route table. The static route has disappeared. So let's go back to the diagram for a minute and see what we have. So in the previous exercise, we saw how we can use simple static routes to reach a subnet via a particular next up address. In the following exercise, we will use 3 different types of static routes to achieve full reachability within our network. The 3 types of static routes are the aggregate routes, the default routes, and simple routes, which we've already configured in the previous exercise. When used together, they provide enough flexibility to handle every routing situation and requirements. From the network diagram, CE1 only needs to know how to reach PE1 or PE3. If we're going into redundancy, for now, let's ignore PE3. This will be covered in the BGP exercise. So CE1 really only needs to know how to reach PE1 and send any network that it does not know about to PE1 and let PE1 route it out for CE. So a default route is a single route that sends traffic destined to any destination to a next up address. And in our case, like I said earlier, this is PE1. Now, again, if you look at PE1 and PE2, so let's look at it in terms of ISP. So ISP1 has a range of 140.10.0.0/24, and ISP2 has 150.10.0.0/24. So from PE1's perspective, every node that's got the 150.10 address resides in ISP2, and likewise PE2 knows that any node that's got the address of 140.10.0.0 or within that range is in ISP1. So really, all PE1 and PE2 really needs to know is, how do I get to the subnet of PE1? So for that, we use a particular type of static route called the aggregate routes. We will now go into the CLI and configure these routes. I have gone ahead and initiated CE1. So let's go to the CLI of CE1 and see what we have. We currently have an interface going to PE1 on the 140.10.0.102/30. It's currently up. Configured it with the physical port 1/1/1, and on PE1 I've gone ahead, I've done the same thing. I've created an interface to CE1 and I've given it the 140.10.0.101/30. Again, let's go back to the diagram and you'll see this is the link we're talking about here, 102.101. So as mentioned earlier, all CE1 really needs is a default route pointing to PE1, which says any network that is not local to me, handle it for me, send it out. So that's the CLI and configure that on CE1. And to do that, we initiate the same command. They're all similar commands, but the syntax are similar, but the variables are what makes them different. So we configure router static route. This time around we're going to use the default route, which is 0.0.0.0/0, which says any network that does not belong to me, that is not local to me, I'm sending it to the next up IP address of PE1, which is the 140.10.0.101. It return. That is all we need to do for the configuration of a default route. Back to the diagram again. We've now said to CE1, anything that is not local, send it to PE1. So we now go on to PE1. What we want to do now on PE1 and PE2 is configure the aggregate routes, which says that is going to 150.10.0.0/24, send it to the .98 address, which is the next up for PE2, and the reverse for the 140.10.0.0/24. So let's go to and finish that off. So from PE1, we want to configure an aggregate route. So configure router static route, but this time around we want from PE1 to go to PE2, which is 150.10.0.0/24, and the next up we want it to go to the next up IP address of PE2, which is the 140.10.0. I believe it's actually I'm on the wrong. Actually, I'm on the right one. So we want to go to .98. .98. So that concludes the configuration of an aggregate route from PE1 to PE2. We then go to PE2 and do the same thing. Configure router, static root 140.10.0.0/24. Next up, we want to go to the 140.10.0.97, which is the IP address of the interface to PE1. Hit return. We've configured aggregate routes from PE1 to PE2 and PE2 to PE1, but we still need to do something, and that we need to now tell PE1 the networks that belong to CE1. Otherwise, this is not going to work. So from PE1, we need to configure simple static routes. Again, configure router, static route. So what are the networks on CE1? We've only got two. Actually, we only need one this time around. We want to get to the system IP address, which is the 140.10.0.12. So 140.10.0.12/32. Next up is the interface IP address, which is going to be the 102. It's going to be 140.10.0.102. Now we've built our network based on what we discussed. Now let's simulate some nodes within this network. So from PE1, let's create a loopback address, for instance, which was going to simulate one node for us. So let's go and do that. So configure router interface. Let's call it loopback test 1. We give it a keyword of loopback just to let it know it's a loopback address, and then the address is going to be 140.10.0.33/32. We don't need to do this, but let's just issue a no shutdown. So we've got a simulated node on PE1. Let's go over to PE2 and simulate a node there as well. So configure router interface loopback test 1. The names are only locally significant. You can use the same name on two different nodes. It doesn't matter. Again, tell it it's a loopback, and the address is going to be 150.10.0.33/32. No shutdown. Let's now go over to CE1 and ping PE1 system address. Ping 140.10.1, actually 0.1. Yes, we can get to it. Let's now see if we can. So what we've just proven now is from CE1 we can ping the system IP address of PE1. Let's see if we can ping that simulated node, which is the .33. So again, ping 140.10.33.10.0.33. Yes, we can. So we can get to the nodes within ISP1 from CE1 via the default route that we created. Now let's take it one step further. Can we get to the system IP address of PE2? Let's find out. So 150.10.0.1, which is the system IP address of PE2. Yes, we can. So we are going from CE1 straight to PE2 via that single default route that we created. We did not need to create multiple static routes here. It's not needed. We only needed one default route saying anything that I'm not aware of, send it to PE1. PE1 knows how to get to PE2. PE2 knows how to get back to PE1. PE1 knows how to reply back to CE. So again, let's see if we can ping the simulated node on PE2. Simulated node IP address is .33. Yes, we can. So I'm going to turn on debug on PE2 and we'll see what the packets are saying. So log, configure log ID. Let's use 33 from debug trace to session exit debug router IP IC MP. We've seen the debug from PE1 to PE2, so we don't really want to see that again. So let's see what it says when we do ping from CE1. Let's see what the ICMP packets are saying. So we're pinging that node on PE2. So it's going directly. We can't say it directly, but let's just read through this. So it's coming from the system. Like I said earlier, when you ping a remote IP address, it's automatically the source IP address used for that ping is the system interface. So it's coming from the system interface of CE1 and it's going directly to the simulated node on PE2. And again, the reply is coming back the other way. So this is how we use default routes, aggregate routes, and simple static routes to achieve reachability within the network. Now, this is used within a very small network where you don't want to enable dynamic routing. Maybe you've just got a few routers here and there. It's quite useful because the overhead on the router is quite low, and it depends on what kind of router you're using. If you have a very small router, you can use that. I mean, the NOKIA is quite big anyway, but this has its own use cases. You can go on the NOKIA website and check that yourselves, or from whatever design you're trying to achieve. So as you can see, we have completed this exercise, and I really do hope you find this useful. And again, thank you very much for watching. And please, if you've not subscribed, please do subscribe and share this with your friends. There will be more videos coming. As you can see, the network or the configurations are getting a bit more complicated, and they're still going to get a lot more complicated when we start talking about OSPF, BGP, and all the other stuff that we're going to get into. So, like I said, if you're following along, please, share this with your friends. Thank you for watching.